Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Boiling point depends on intermolecular forces, hydrogen bonding, dipole-dipole interactions, and London dispersion forces. Compounds capable of intermolecular hydrogen bonding, NH or OH donors, have significantly higher boiling points than structurally similar compounds that cannot form such H bonds. Analysis of each option. Option A: cyclopropanol, first, versus oxetane, second. Cyclopropanol has an OH group and can form intermolecular hydrogen bonds. Its boiling point is ~101 degree C. Oxetane is a cyclic ether with no OH or NH. It can only act as H-bond acceptor but not donor. Its boiling point is ~48 degree C. So the first compound, cyclopropanol, has a higher boiling point. This does not satisfy the condition. Option B: acetone, first, BP ~56 degree C, versus 2-methylpropene, isobutylene, second, BP ~7 degree C. Acetone has a polar C is equal to O group and a higher boiling point than isobutylene, which is a simple alkene with only weak London dispersion forces. The first compound has a higher boiling point. This does not satisfy the condition. Option C: ethylene glycol, OCH2CH2O, first, BP ~197 degree C, versus 1-propanol, CH3CH2CH2O, second, BP ~97 degree C. Ethylene glycol has two OH groups, enabling extensive intermolecular hydrogen bonding, giving it a much higher boiling point than 1-propanol. The first compound has a higher boiling point. This does not satisfy the condition. Option D: 1-methylpyrrolidine, first, versus piperidine, second. 1-methylpyrrolidine is a tertiary amine, NCH3, no NH, so it cannot form NH. N hydrogen bonds. Its boiling point is ~80 degree C. Piperidine is a secondary amine with an NH group, allowing intermolecular hydrogen bonding. Its boiling point is ~106 degree C. Therefore, the second compound, piperidine, has a higher boiling point than the first compound, 1-methylpyrrolidine. This satisfies the condition. Why other options fail? In A, B, and C, the first compound either has stronger H bonding polarity or more OH groups than the second, giving the first compound the higher boiling point. Therefore, the correct answer is D. Therefore, the correct answer is option D.